Last week, OpenAI released an article called Why Language Models Hallucinate. In it, they don't just explain why hallucination happen, they also suggest a possible solution. But here's the real question. As a developer, what can you learn from it? Stick around because I promise this insight can boost your productivity. Before we get there, take a look at this GitHub repo. It's called Spec Kit and it's also released last week. But how it is related to hallucinations? Don't worry, we'll get to it in a moment. First, what are hallucinations? Hallucinations are a plausible but false statement generated by language models. They can show up in surprising way, even for seemingly straightforward question. According to an MIT report from last month, 95% of AI pilots failed. In a survey they followed, the second top reason was model output quality concerns. In other words, hallucinations. They are one of the biggest reasons developers lose trust in LLMs and in some cases stop using them. But before we understand why hallucination happen, we need to look at the basics of how these models are trained. Of course, the full process is way more complex, but I'll cover the key concept you need to know. Let's imagine we're LLM developers at OpenAI. We start our morning with a brand new model that hasn't been trained yet. First, we need to feed it with relevant data. This could be a massive dataset of books, open source repositories, articles, you name it. Usually, the data is clean ahead of time and it's valuable and consistent. Then comes the reinforcement learning phase. Here how it works. We ask the model a question it should know the answer to based on the trained data. Since we already have a ground truth, we can check its response. If the model answers correctly, it earns points. If it's wrong, it loses points or just doesn't gain any. Over time, the model is motivated to get the highest score possible by producing more accurate answers. Now, to measure how well it's going, we run it against benchmarks. These are the standard tests that the AI community uses to compare every new model. If the benchmark scores aren't good enough, we can train it on more datasets and try again. But here's the catch. Overtraining. Push it too far and performance can actually get worse or introduce new problems. Okay, hope you survived this part. But why do hallucination happen? According to the full article, the main reason hallucination happen comes down to how popular benchmarks are designed. Most of them use binary grading, basically yes or no questions. That means if the LLM is correct, it gets rewarded. If it's even slightly off, it gets nothing. Two top development benchmarks are IFE-Val and SWE-Bench. Both work exactly like this. Here's a simple example, not from the development world. If I ask the LLM, what's Donald Trump's birthday? As humans, if someone says sometimes in June, we'd count that as a decent answer. But in the LLM's mind, that earns 0 points. The model only gets rewarded if it says the exact date. So what does it do? It tries to guess precisely, almost like playing the lottery. And for the record, Trump's birthday is June 14. So sub and like if you want more info about Trump. But is there actually a solution for this? OpenAI suggests changing the benchmarks so they don't just grade right or wrong. Instead, they have 3 outcomes: positive, negative, and I don't know. That way, the model learns that sometimes it's better to admit uncertainty instead of guessing. Back to our Trump birthday example. +1 point for the exact answer, 0 points for saying I don't know, -1 point for giving the wrong answer. What do you think about it? Would you rather get an I don't know answer from the LLM instead of a bad guess? Drop your thoughts in the comments, I'm curious. Another approach they suggest is building a database for common questions. So when you ask something simple like what's 5 + 10, the model won't risk making an embarrassing mistake. But as developers, we don't expect it to have a giant database covering every possible code use case we'll ever need. So what can we do instead? What if I told you the LLM could actually test its own code first and only suggest it if it works? That's exactly where GitHub Spec Kit, the tool I mentioned earlier, comes in. With Spec Kit, you can implement spec-driven development using Cloud Code, GitHub Copilot, Gemini CLI, or Cursor. The idea is simple. You write the test before any new code is generated, then the LLM checks its code against those tests before making changes. In other words, the test acts like a judge, blocking bad code and stopping hallucinations before they ever reach you. And in the next video, I'll show you exactly how to use GitHub Spec Kit step by step, so hit the subscribe to get notified and give the video a like if you find it valuable. See you in the next video.